This video, like all of my demonstration videos, are for computer simulator pilots. In this video we're going over the basic controls of a Cessna 152 or Cessna 150, very similar, for flying a circuit at an uncontrolled aerodrome. Now, like all of the videos, we are focusing just on the basic instruments and handling. If this was a real flight, we'd be using a checklist for every step along the way. You always use a checklist. You never rely on your memory for doing any of this. So for the purposes of this video, we will assume that a checklist was used. Also, radio calls we're not covering on this video. If it was for real at an uncontrolled aerodrome, we'd be making radio calls to announce to any other traffic that happens to be in the area who we are, where we are, and what we're doing. So let's get started. We're in a Cessna 150, a two-seater Cessna. We have light load, so we'll have good performance, so we're about half fuel. Now we're sitting at an altitude of 860 feet above sea level. Now if this is the runway, we're going to be doing a circuit. So we're going to take off on the runway, turning left 90 degrees. So that'll be a heading of 290, climbing another 500 feet up to 1,000 feet, turning left again, heading in the opposite direction that we are now, which would be 200 degrees at 1,000 feet above circuit. Then we're going to turn left again, descending at 500 feet a minute from 1,000 feet above the ground to 500 feet above the ground, where we'll turn left, pointing straight at the runway, descending the remaining 500 and doing a landing. So that's a circuit. We do it as square as we can. So since we're pointing at the heading of 20 degrees, 020, we check on the compass. The compass will spin during turns and descents, so we use the mechanical gyro compass set to the compass because it stays stable. So we're setting at the right heading. Airspeed, cruising at 100, take off at 60, and climb and descent between 70 and 80, depending on flap setting and airplane loading. Stall speed is down into the 50s, so we don't want to go there. The wings will stop flying, which is very dangerous. Now, all the other controls. Throttle, you push in for advancing the throttle. Carburetor heat, pulling it out blows hot air into the carburetor. Now you need that because if your RPM drops out of this green sector, you pull the carb heat on, and that'll add hot air to the carburetor, melting any ice that may form at the lower RPM settings. It's a safety thing, so we'll have that on for all descents and all landings, anytime the RPM is lower than 2000 RPM. Mixture control, we'll leave it full rich for the circuit today because at 6,000 feet you have to thin out the amount of fuel going to the carburetor to match the less dense air that's going into the carburetor at high altitude. Trim wheel, roll it up, pitches the nose over, rolling it back, pitches the nose up. That way, on long flight legs, you don't really have to be pushing or pulling on the yoke to maintain direction. Trimming the plane every time you set up for a new attitude is really important. Yoke movement, well, to initiate a turn, you turn it, and the amount you turn it determines how fast you turn. Once you've reached the angle of bank you want, you immediately center the controls. Centering the controls, you maintain that bank angle and you maintain your turn. If you keep the yoke turned one way or the other, the plane will roll right over onto its side, which is not good. So initiate a turn and then center the controls to maintain that turn. Rudder pedals at the bottom work the tail rudder and the nose wheel. So outside view, we'll take a look at the plane here. I've got the flaps down about 10 degrees, just to show that, and we'll bring them up for takeoff position. We're going to be using a lower setting for flat landing, right about there. If it's a very short field, we'd use full flaps, but a nice smooth landing is done at about 20 degrees flaps. Rudder, right and left, left with left pedal, right with right pedal. Aileron, rolling left and rolling right. And neutral. Elevator, full back, pitch up. Elevator down, pitch forward. So push forward, pitches forward. Now generally, the controls work kind of backwards to what you might think. Throttle makes the plane go up and down. Pitch controls the airspeed, kind of opposite to what you see in the movies. But the two do work very closely together. So we're getting ready for the takeoff. We'll climb to 500 feet, turn left to a 90-degree turn heading of 290 until we're 1,000 feet above the ground. We'll climb on the VSI at 500 feet a minute. So that's 500 up, 500 down. And the turn and bank indicator, the little airplane. If you tip or bank the plane until the little plane lines up with a white line, that's a 20-degree bank. The ball tells you whether you're slipping inside the turn or skidding out away from the center of the turn. To correct it, use rudder. So if the ball slides to the left, you step on the left rudder. So that's correcting for a skid. If the ball slides to the outside of the turn, or to the right in this case, if we're turning left, then you step on the ball with your right pedal, and that will prevent the plane from slipping. So you just work the rudders until the ball stays in the center. It's very simple. So the rudders during flight are used to coordinate turns. Rudders are used during landing and takeoff to keep the plane going straight. So carb heat is full off for takeoff and climb and cruise. Mixture flaps are up to 0, mixtures at full rich, parking brake off, and we're ready to go. Slowly advance the throttle. Use a bit of right rudder to counteract for the engine torque and keep it straight down the runway. So neutral controls just straight down the runway until the airspeed advances up to 60 knots. So it's at 40, 50, and 60, rotate. So gently pull back on the yoke, but firmly. And with the trim wheel set at takeoff position, the plane should balance out to 500 feet climb or more. We are a little light today, so it'll probably climb faster. Airspeed's climbing out at about 70, which is good. And we're on the heading of 020, the same as a runway. So we do this until we go up 500 feet above the ground, which will be 1,300, right about there, just over 1,300. Okay, so that's 500 feet above ground level. Again, the altimeter's reading above sea level, so you have to take into account the field elevation. Now, we're at 500 feet. We're still climbing at 500 feet per minute, so we initiate a turn and we'll roll out on a heading of 290. That'll put us perpendicular to the runway. So we're rolling out, we're still climbing, and we just maintain this attitude, and the trim is good, so we can take our hands off the yoke until we get about there. That's circuit altitude. So that's 1,000 feet above where we were. So the big hand has gone around once. So we can relax for a bit. Now remember, pulling back on the yoke makes the plane go up, but that means it'll slow. And when it slows, it reduces lift. So you end up at the same altitude, just going slower. If you advance the throttle, you go faster, you create more lift, you start climbing. And if you climb, you slow down. So you end up at the same speed, only you're climbing. So throttle controls up and down, and yoke pitch controls airspeed. So we're at altitude, we're turning, and we're going to roll out at 200 degrees. That's heading right back in the opposite direction. So we're rolling out, we're maintaining our circuit altitude, we're a little low, we'll bring it up a bit. And now we're going to retrim the plane because we are now not climbing anymore, we're flying at cruise. So the RPM pulls back to cruise RPM, which is 2250 or 2300. Quick look, there's the airport parallel to us. Turtle Lake right under us there, it's a good reference. And pick a landmark straight ahead, the big opening of that bay. That is in the direction we want to go. So it's better to look at that. It's more accurate than looking at your gyro compass. Right? If you can see where you want to go, you just go there. Okay, things have settled out. RPM's good. Now we're mid downwind. We're getting ready to land. So pull a carb out and leave it out until we land. Okay, because we're about to pull power off and descend. Once the end of that runway gets at our 7 o'clock position, we'll initiate our left turn. We'll descend at 500 feet per minute with an RPM at around 1500 or maybe 1700 and heading at 100 degrees, which is perpendicular to the runway. So we're at circuit. Now we're pulling back and slowing the plane so I can put the flaps down. So we're about 60-65 knots. There's the flaps down to 20 degrees. Repitch the plane, or retrim the plane. Initiate our turn, descending at 500 feet per minute. Power is down to about 1900 right now. It'll go a little lower until the turn's over, then we'll drop it a bit. Airspeed's at 70, that's good. We're rolling out at 100 degrees, that's correct. And continue our descent down to 500 feet above the ground. So that's just past 1300 feet indicated. Turtle Lake and the runway at about 11 o'clock. Okay, so we're still about 700-800 feet above the ground, 700. Descending at 500 feet a minute, RPM is good. Airspeed is 70, that's good. Checking the position of the runway. So we want to turn when we're 500 feet off the ground and it just about in line with the runway. If we do this right, those two will come together. So that'll be any time now. Right about now. Now, a bit of power is a good idea. We're going to turn, we're going to lose lift. So power up a bit, pitch up a bit, like you're doing a turn, like a descending turn. Otherwise, you'll lose altitude. So we're still at 500 feet a minute, so we did that right. Now we're lining up with the runway, best we can. Use rudder a lot here, because at a relatively slow airspeed, ailerons could induce a wing stall, so it's best to use your rudder for directional correction. Heading is good, we're in line. Well, we're a little to the left actually. Your body should be right in line with the center line, so we'll correct and pull it over a bit. 500 feet, power is good, airspeed's good, fly it right down to the end of the runway. Once you're down there, slowly pull the power to 0 and pull the plane up level to the ground. Keep it level. As you lose airspeed, the nose will want to drop. Don't let it. So as you slow down, gradually pull back, but don't balloon up. Keep it level, 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 and the plane will land when it wants to. And there you go. We're on the ground. Perfect. Steer with your rudder. Lift the flaps up if you have a chance to, and brake and full back on the elevator. Full back prevents any nose overs or minimizes it. Parking brake on. Now normally we would clear the runway, but we'll just stop right here in the middle. So the flaps are up, plane's still running, and we've done our circuit.